Okay, thanks everybody for joining today. Paul and I are excited to give you some pointers on diagnosing the Select Liftgate charging system. If you were on the last webinar, some of this material is going to be similar to the direct diagnostics. So some of the things we're going to talk about today, some of the changes that have occurred over the years, basic function of the Select system, diagnosing the Liftgate charging system, and then diagnosing the input source, being the tractor or the reefer. With the Select system, you have multiple sources of power that you can pull from, so now we're going to talk about tractor and reefer. First off, the most noticeable change is the decal on the front of the Select controller. You'll see on the left there's a white label, and on the right is a blue label. And there's some reasons behind why we went with a blue label decal. It makes it easier for us to denote some of the changes, and easier for the end user, when we're talking, over the phone, helping with the diagnosis. That's a really good indicator that we can ask for to go over the changes. And one of the first changes is a voltage threshold change. Again, we get that power from somewhere to turn our DC-DC converter on to charge those liftgate batteries. Some of the earlier models, that voltage set point was 13.2. So being that the tractor or the reefer, in order to reach those voltages, they had to be running. So we put that 13.2 setting in there. With the new blue label, that voltage threshold is now 13.8 volts. And one of the biggest reasons why we had to add that 13.8 is due to the addition of the severe service cables. As you can see in this diagram on the right here, you'll see the large red cable and the large black cable that are directly connected to those liftgate batteries. So when those are in place, that's a direct connection from your source, being the tractor, to those liftgate batteries. And we had to put that 13.8 volt threshold in there because essentially it creates a loop. So our DC-DC converter thinks that the liftgate batteries are the input source. So we put a higher threshold in there to kind of eliminate that scenario where it would charge off the liftgate batteries. So if you have an application where you have these large cables in parallel with our system, it's necessary to have that blue label Select to properly charge those liftgate batteries. Severe service meaning lots of lifts, not a lot of time in between stops. Up in the colder climates, that's where that severe duty or severe service cable would be necessary. Also, another threshold that was changed is the 9.5 volt shutoff threshold, and that's due to the 7-way Aux circuit, protecting that circuit. When voltages reach that low of a voltage, we must shut off our system and quit pulling power from the Aux circuit in order to save energy for that ABS circuit. We cannot jeopardize that circuit. We used to start out at 11 volts, and we kind of opened that window up a little bit further and dropped it down to 9 volts. Some of those troubled trucks that just drop to that 11 volt range quickly, it can now drop down to 9.5 and still be safe for that circuit. And I'm going to let Hall go over some of the LED functions.
Okay, hey everybody, sorry, I just saw somebody posted a note that the sound might be having some difficulties. Celia and Holly are on that to fix any technical issues we're having. Please let us know if it continues. Yeah, so like Jimmy mentioned, we have, I'm going to be talking about just the general functionality of the Select system. So with this system, we can have charging sources from the tractor, from the dual pole or single pole, from the 7-way, or from the reefer. So if you look at the picture on the screen here, the top 3 LED lights are for those input sources, and the bottom light is for the lift battery source. The good thing is that all of these, along with our lights on our other systems, have the same blink codes indicating if it's on or working or whatnot. So if those lights are solid green, it means the system is charging. That's staying above that 13.8 volt threshold that Jimmy was talking about, and the system is on and working. If those lights are only blinking green, then the system is not charging, but the voltage is still good. So it's saying essentially the tractor isn't turned on yet, or the reefer's not turned on yet, but I'm sensing good voltage coming from there. So somewhere between 12.4 and 13.79 volts. It could also be at the liftgate battery. It's saying, okay, my voltage is above 12.4 volts, but I'm not seeing that starting voltage, so I'm not currently charging. So it's not necessarily anything you need to worry about. It's just something that's saying, hey, the system's not on and working yet because the source isn't currently active. If the source is active and you're still seeing that blinking green, that could be an issue, and we're going to get into that here in just a little bit.
Yeah, that's one of the, just to add to that, Hall, that's one of the most misunderstood on the LEDs. Just one thing to burn into your head is it's not charging if it's blinking. If it's solid green, it's charging.
Yeah, exactly. Thanks. So just to dive into that a little bit more, there is one other blink code that you might see, and that is the blinking orange. So again, anytime you're seeing a blinking light, really, it's telling you that the system's not currently charging. With that blinking orange light, it also means the batteries are discharged. So that could be anything from 12.37 volts, where, you know, as soon as you turn it on and it gets a little drive time, it'll charge up and be okay. It could mean that it's severely discharged all the way down to, 8 volts. So it's just kind of telling you, hey, there's something going on here. We're not fully charged. Something you may want to look at, check before you send that trailer out on the road. But like I said, it's kind of a range there of what that could be at. Again, blinking green, showing that there's good voltage. And then you might also have a state where there are no lights on the front blinking at all. And generally there's 2 causes for this, both of which are essentially cutting off power to the front. So all that no light means is that there is no power getting to the front, getting to that box. And so it just has no source to power even those LED lights. And we'll go into right now, well, after this next slide, of what exactly causes that and how do we diagnose that. So just real quick, the source LED, again, we talked about it before. All of our LED lights have the same blink codes, but just want to walk through this real quick. So again, if the source light, so if you plug in the truck and it's blinking orange, that just means that the voltage is low. So as we'll talk about later, it might mean that there's a blown fuse or a open circuit, or it might mean that, or excuse me, not open circuit, a blown circuit breaker. It might also mean that there's just a bad cable, maybe a dual pole cable's got a cut in it, or a 7-way cable or something like that. But we'll get into that later. So we're going to go real quick into diagnosing that no light, no LED on the Select controller.
Just real quick, Paul, before you go further, we had a question come in on, what if that voltage is right at 12.4? That is that threshold. It should be blinking green if it's right at that 12.4 range. Mm-hmm. Anything below that's going to be blinking orange.
So if you're not seeing any LED lights on that Select controller, there are 2 issues that could be causing that. The first one is, and the first thing we have people check, is this 2-amp fuse in the battery box. So if you look in this picture on the slide, just below that plug, you see the fuse holder. That's the 2-amp fuse. It's connected in line with the power system in order to avoid any damage to the controller on the nose of the trailer during install. So if it's getting installed and something gets shorted, We had instances back years ago before we put this in place where that power would shoot up to the front of the trailer and burn up the controller, and it would cause significant issues there. So we put that 2-amp fuse in line to protect that. All that wire that it's doing, so you can see it's in line with that orange wire. All that wire does is send a signal up to the front, so it's very low amperage going up there. So just want to make sure if it does blow that you're replacing it with something else that's very small. You don't want to replace that with anything larger because, again, that's controlling those special circuits within the control module to make sure that nothing gets damaged in there. If you test that fuse and it is still good, next thing you want to do is test the voltage at the orange wire in the battery box. So as you can see in the picture, there's a multimeter. The lead is on the ground and on that orange wire. And what you're looking for there is anything above 6 to 7 volts. We'll talk about that later. That 6 to 7 volt range is where our system kind of cuts out. So you're looking for anything really above that threshold at that orange wire. And if you have that voltage, then your lights should be good up front. So if there's still not lights up there, next thing you want to check is the same wire up at the front in the select controller. So you're essentially just tracing the circuit back. You've checked the fuse, it's good. You've checked the stud at the battery box, it looks good. So now we're following that cable up to the front and checking that at the select controller. Again, we just look for that 6 to 7 volts or above. If you saw it at the battery box, but you're not seeing it at the select controller, then you want to check along that harness, and there's going to be some damage along the harness that's keeping the signal from getting to the front. If you do have power up there at the front, then you might have just a faulty LED on the controller, and that's a warrantyable thing. So generally, we don't see too many issues along that, though. We do see when this comes up, typically it's a blown fuse, or as we'll see in the next, or as we mentioned before, it might just be really low voltage back there at the batteries. So again, it's got to see above that 6-7 volt range. So those are kind of the first two things to check, and then again, just following these procedures.
All right, thank you, Hall. And we put all this together. We tried to put all this together in order. So you got to make sure you have power first, which Hall went over. The next thing is, if it's not charging, these are the steps that you would have to take if the system's not charging at all. And we kind of try to put these together in order to keep you from, when it's not charging, you're not trying to chase something and figure out what the root cause is. If you follow these steps in order, you'll get to the root cause. Step one being, couple the tractor to the trailer. A lot of shops, they use like a roll-around cart with the battery and a charger to power our system up. Plug it in, via the 7-way, the dual pole. Just one thing to note on that, if you are using a roll-around cart, with that battery and that charger needs to at least be a 40 amp charger. Again, it's got to be able to support a 20 to 30 amp load, which our DC-DC converter in the Liftgate battery box is going to do. So if you're going to do that, that's fine. Just make sure it can support the load. Once you have it tractor coupled or your test fixture coupled to our system, make sure the LEDs, you get the solid green LED on your source, your solid green on your lift battery. And again, to do that, with the blue label select, you must achieve that 13.8 volts to start that sequence. With the white label, it's still 13.2 volts. Next, you want to measure the voltage at the input wire on the select controller. You want to make sure that you are getting voltage on your input. That's input from your tractor. You should read tractor battery voltage. If no, then you can look. The most common place to look is the 30 amp fuse, source fuse, whether it's the Stinger that you're testing, the Reefer, or the auxiliary circuit. So make sure that 30 amp green maxi fuse inside there is not blown. Third step, measure voltage on your ignition. You want to make sure that you have, so once we've achieved that 13.8 volts, our system should send a signal down that yellow wire back to the DC-DC converter to tell it to turn on. That's basically, it's an on and off switch. You must read 12 to 13 volts on that yellow wire inside that select controller, as you can see in the diagram on the right there. Just take your voltmeter, negative lead on the white wire, positive lead on the yellow wire, and you should read 12 to 13 volts. If you do not read that voltage there, inspect that yellow wire and make sure it's got a good clean connection. I've seen where the heat shrink will slide up a little bit too far, and when they tighten the nut down, it tightens down over that heat shrink, not giving it a good connection. So make sure you have a really good clean connection there. So now we're going to go back to the liftgate battery box and take some measurements. Step 4, measure the voltage at the 4-pin plug. Before I go any further though, this is a good time when you unplug this 4-pin plug, inspect it and make sure it's clean, make sure there's none of the pins are burnt. Specifically on the black wire, pin number 1, this is the last point in that circuit where that input comes in. So the voltage is going to be at its lowest at that point. So when our charger's maxing out, a lot of voltage drop, the current's going to be at its highest. So if there's any imperfections in that circuit, right there is really where it's going to show. So make sure that plug's not burnt. You work with our warranty department if you need to make sure that's replaced. But don't go any further if that's burnt. Place positive lead on the pin number 1 black wire, and negative lead on your pin number 3, which is your white ground wire. Make sure you have voltage there. If no, the issue is between the 4-pin plug and the select controller. Next step is measure voltage at the 4-pin plug on pin number 3 and the ignition wire. We check the ignition up front. Now we want to check the ignition back here at the back. We want to make sure you could have that voltage at the front. There may be something wrong with that yellow ignition wire between the select controller and the liftgate battery box. So make sure you're getting that 12 to 13 volts right at that 4-pin plug, because that's where it really matters. If you don't have 12 to 13 volts, then you know there's an issue with that yellow wire, and you can kind of chase it back. Make sure it's replaced. Step 6, measure voltage at the 4-pin plug. That's pin number 3, the ground, and your output. Make sure that you have a good connection from your output wire, which is the red pin number 2, to your liftgate batteries. When you put your voltmeter on that, you should read liftgate battery voltage. If you don't, chase that circuit back to the liftgate batteries. The connection points there's a red stud up at the top where it connects the 4-pin plug to this red stud, and then it goes to a 30 amp circuit breaker, which is typically mounted on a L bracket. There's a little yellow arm on that 30 amp breaker. If it's tripped, you'll see that little yellow arm. So just make sure you reset that breaker. And if all that's good, check your connections. Make sure you have a good clean connections. Nothing's cut. But you should read liftgate battery voltage here.
So I'm going to take over and talk about a few other LED scenarios you might see. The first one we're going to talk about is a rapid flashing orange light on one of the LEDs on the front. So this can occur on any of the source LEDs or the liftgate LED. And 99% of the time, what this indicates, it's just a fault that we built in to the system to indicate that there's a blown fuse on that circuit in the select controller. So we'll walk through just in just a second once you open that up, which fuse goes with which circuit and whatnot. But 99% of the time, if you see that rapid flashing orange light just on one of the LEDs, that means it's a blown fuse. If all those fuses do look good, it could be that there's an open circuit, there's something cut in there. So you just want to check those cables at the front, make sure the connections are good, make sure all the there's no corrosion, everything is connected. But personally, in my experience, anytime I've seen this, it's always been a blown fuse. So when you go to test those, you want to take your multimeter, set it to ohms, place positive negative lead across the fuse, and you want to check it, look for a 1 ohm or less reading that indicates that fuse is still good. If you get an OL reading, then that indicates a bad fuse. We recommend that just to make sure you're precise, just to make sure that you're getting that firm reading. You could also do a continuity test or something like that, but that can be misleading at times. If you're not sure exactly how much of that connection is still there, it can be partially disconnected or whatnot. So we recommend using that ohms feature on the multimeter to check that.
Yeah, just like I said, you want to be sure. You can hold those fuses up to the sun, and 90% of the time you're going to tell if it's blown or not. But there's that small percentage that it truly is blown, but it doesn't look like it when you're actually looking at the fuse. So to be sure, use a meter.
So like I mentioned, just kind of walk through, since there is kind of a lot going on in here. The LEDs on the front, if they are flashing green, or if they are flashing orange quickly, that will indicate most of the time a blown fuse. So we have 4 fuses in here, 1 for each circuit. So we have, if you're looking at this picture, the bottom horizontally placed fuse will be your ground fuse. The top horizontally placed fuse is your stinger dual pole single pole fuse. Then we have the 2 vertically placed fuses on the right. The one on the left of the 2 is for your aux, and the one on the right of the 2 is your reefer. And you can see here we kind of situated as best we could these studs in conjunction with these. So the studs for the stinger are on the top left, similar to that fuse, and then it kind of goes down around from there. The next 2 studs on the left are for the aux, and the studs for the right are for the reefer. With those last 2 studs being, as we talked about earlier, for the yellow and orange wires that kind of give the signals powering, telling it to turn on and off, and just that there's enough power to turn on. So this photo comes along printed out with all of our systems that we send. So ideally it should be in the battery box. If it's not, on our resources link, or I forget what the exact term for it is, but the thing at the bottom of your screen where it says resources, there's a diagnostic guide. This exact thing is in that diagnostic guide. That is also found on our website. And if all else fails, you can call our warranty department or email us at warranty@purkeys.net, and we can get this sent over to you. So try to make this as accessible for everyone as possible, so everyone knows what they're looking at. There is a lot going on in there. People ask why we fuse the ground circuit. We have found that this is extremely important to do because in some of our older systems, we're connected so much with the liftgate pump motors and with the liftgate systems altogether, that if there was not a good ground on the liftgate side, there would be 150 plus amps that are trying to find some ground, and they would inevitably find ours. And so they would be trying to push 150 amps through our little 8-gauge wire, and it would not go well. As you can see in this picture, we would have significant heat buildup, and there could be burning or melting of that wire. So we ended up fusing the ground circuit to keep that harness safe and to keep our system safe, in order in case that does happen.
Yeah, it's much easier to replace a 30 amp fuse than 50 foot of 4-conductor harness.
Yeah.
And one thing to add to that too, all the wire that we use in any of our products is all GXL rated wire. Basically, mean it will not, you will not get a flame out of it. If it does overheat, it'll just char the cable. So we do use really good special wire for all these applications.
Okay. The last LED scenario that you might see are just blue LEDs. So what this indicates is it's just a startup sequence. So if you have to disconnect the system from the batteries altogether to change them out or whatever it might be, even just to clean them and then you reconnect it, then you'll see these blue LEDs lighting up just to indicate everything's restarting. They should go away after a minute or two. It's just allowing it to do the checks, make sure that all the cables are there, all the senses and voltages that it needs are there, and then that should go away, and you should get the blinking green lights indicating that it's ready to go. If for some reason those LEDs stay lit, that usually indicates that the liftgate batteries are between that 6 and 7 volt kind of window that we talked about earlier, where they don't quite have enough voltage to turn on, but maybe they have enough voltage to sense that there's something there. So if that's the case, you want to charge and test the liftgate batteries, make sure they're still good, charge them up a little bit, and then reconnect. That should go away. If they're still turning blue, then there's probably something else going on there, some defect to discuss, but I've never seen that happen. It's always been one of these two scenarios. So
yeah, most electronics need that 6 to 7 volt range to operate. So if it's in that range, it's just going to do some funky stuff. And we've just ran across where it actually just stays in that. It could be, all solid red, all solid green, or the solid blues on all the lights. So if you get that, it's just in, like Cole said, it's in that funny voltage range where it doesn't want to work properly.
All right, Jimmy's going to run you through diagnosing the source.
Okay, so before I get started on the input source, we had a question come in on, basically it's the bypass system, the red switch in the battery box. Well, the question reads, when I turn the switch in the battery box on the trailer to the number 1, why do both lights go out on the box on the front of the trailer? Basically, this is a red switch that we incorporated. It's mounted in the liftgate battery box. In case something were to ever happen to the DC-DC converter charging system, they could flip it over to the 2 position and just run the traditional dual pole charging cables. Basically, this is just to get you out of a bind, get the gate off the ground, and get that trailer back to a shop. But the question, when I turn the battery box, the switch to the number 1, why do the lights go out? It actually should be, if you switch it to number 2, the light should go out. So there may be something miswired on the back of that red switch. Feel free to call, the warranty department to resolve that, but it's likely that something's miswired on the back of that red switch. And again, you can go back to the user guide, the resource list, and to look for the correct wiring for that red switch. So going into diagnosing the input source, being the tractor, dual pole or single pole, Again, you must achieve that 13.8 turn-on threshold on our select controller. Some of the issues I've seen, some of the pictures here are on a dual pole circuit, corrosion. That receptacle is mounted in a pretty vulnerable spot where you can get a lot of road splash, especially up in the north. You got that toxic concoction that are on the roads, just constantly spraying up at this connection. You can see the corrosion built up pretty bad on this one and ended up, as soon as I touched that cable, it just fell apart. So you got to make sure that circuit can handle a 20 to 25 amp load. And typically on a dual pole or single pole, especially on a dual pole, the integrity of that circuit's pretty good because they're dealing with large cable, 4-gauge or 2-gauge cables. But the connection points are key, especially as you can see here. Next, kind of going to go into the reefer, the refrigeration unit. One thing you might see, something that we added to the blue label select, is typically there's a 2-conductor wire that connects our select controller to the reefer battery. We use the starter as a junction point, but essentially it's connected to that reefer battery. With the newer style reefers, they don't have an alternator that takes care of the reefer battery. They either have a inverter or a internal battery charger that takes care of that reefer battery. So if you want to, and also they have a supplemental, like they call it the supplemental power package, which basically it's an alternator that the reefer engine spins to charge an external battery or liftgate batteries on its own path. So if you want to indicate, you can see here on the right, there's it's called the reefer enhancement module. If you want to just indicate what that reefer is doing, if it's charging liftgate batteries, there's a fuse inside there where you can rotate. Position 1, it's going through that module, so we can indicate, kind of giving a little bit of enhancement to that reefer. We can indicate on our select controller if that reefer is charging liftgate batteries. You'll get that solid green light if it's charging. If you want to, the old traditional way, you can bypass that module and put that fuse in position 2. So it's pulling power from the reefer, turning our system on, our DC-DC converter, and it's charging liftgate batteries. So that's one thing you may see different on the reefer harness, connecting the select controller to the reefer. It's just a simple fuse change depending on if you want to only indicate or pull power from the reefer to charge liftgate batteries. Next, we'll go into the 7-way Aux circuit. Looking at the direct controller, you have the 3 options: Stinger, Reefer, Aux. And it's all in that order. We're going to pick Stinger first because the integrity of that circuit is much higher of the 7-way circuit or the Reefer circuit. If that's not available, or you uncouple the dual pole, it's going to move over to Reefer, and then your backup is your auxiliary, your 7-way auxiliary circuit. Same rules apply, though. You still have to reach that 13.8 turn-on threshold. And again, that circuit has to be able to support that 20 to 25 amp load. Being that kind of going into the next slide, the most common fault is excessive voltage drop. This can be seen on the dual pole if you have bad connections, like we saw earlier, corrosion. But typically, you're going to see this more often on the 7-way if there's anything wrong with that circuit. Basically, what you'll see on our controller is we've seen that 13.8 threshold. We told our converter to turn on, so we get solid green lights on the front of our controller. Once that happens, now we're pulling a load through all those connections, starting at the tractor. All the 7-way connections, the 7-way cord itself, the 7-way nose box on the trailer. We got to pull that 20 to 25 amp loads through all of that. And at times, by the time it gets to our controller, it may drop below that 9.5 volt threshold. And if it does, what you'll see is the LEDs it look like a railroad symbol. They'll go orange back and forth. Basically, that means it's just shutting off. Once it shuts off, you lose that load. Now my voltage can raise back up again, and it's more than likely it's the truck side and not the liftgate charging system itself. So you need to tighten connections. Make sure you're using the right 7-way cords. Make sure everything's in good working order. And I went over that already. So I'll let Hall kind of go into how to eliminate this excessive voltage drop.
Yeah, thanks, Jimmy. So if you are seeing this voltage drop indication happen at your controller, similar to what we were doing earlier, we want to start at the beginning of that circuit and kind of trace our way back. So we're going to start at the tractor. And kind of everything we do is geared toward, like Jimmy said, being able to handle and sustain that 20 to 25 amp load that we need, that our system needs in order to function. So first thing we want to check is on the truck circuit, going up and checking the aux fuse, make sure that it's not blown. Also make sure that it's 30 amps. If it is a 20 amp fuse, and we get that replaced and bump that up to 30 amps. I know we've seen a couple trucks in the past that have come with a 20 amp fuse and have kind of had to go through a little bit of a process, but generally it hasn't been an issue, but we need to make sure that is a 30 amp fuse to sustain our circuit. If that is 30 amps and if it is not blown, then we can move down the tractor to the connection between the tractor and the actual cable. So first thing, you want to make sure that if it's on the 7-way, that cable from the 7-way harness on the truck to the connector at the back of the tractor is connected and is in working order. If that is good to go, then you want to check that receptacle, similar to what Jimmy was saying earlier. The 7-way or the dual pole for that matter get plugged and unplugged every day, maybe multiple times a day. Those cables at the truck don't really get plugged in and unplugged very often. So we have seen issues where there is major corrosion buildup there, and you're getting generally good voltage there. You've got a good cable, all of that, but there's just so much corrosion built into that connection because it just hasn't really been handled much. And that's causing issues. So just making sure that every once in a while that's getting unplugged and that's getting checked if there is a voltage drop issue to make sure that that's clean and that everything's in working order on that connection is really important.
And just make sure that, they make stuff to, these cables, dual pole, 7-way, all of this hanging off the back of the truck. Make sure they're properly secured. There are things to keep those secured and hung up so they're not dragging, getting damaged just from dangling too far down.
So if everything looks good on the truck side, then we'll come back to the cable itself. But going to the trailer side of the system and looking at the nose box there, a couple of things that we see more often than others. There will be circuit breakers inside the nose box. Again, we need a 30 amp circuit in order to be able to work with our system. So if those are 20 amp breakers, then one of two recommendations: either switch those out to 30 amp breakers, or you can just take our wire and move it to the hot side of the breaker. As we talked about earlier, we have fuses in there. We have in our system all along the circuits. We have breakers at the battery box. We have all the protection built in to our system, so there is not any issue with moving that to the hot side. And that's probably the easiest, the simplest way to fix any issues that you're having in the nose box because of the size of the circuit breaker. If those breakers are large enough, you want to check the connections. make sure that if you've got a bullet connector, that everything is tight, and that if you do not, if you have a standard eyelet, that it's a good D-style crimp, that everything is secure, that, like Jimmy said earlier, if there's heat shrink on there, that it hasn't slipped down and gotten caught in that connection. Just confirming that everything is tight and allowing the current to get through. And then kind of back to the cable itself, like Jimmy said, first off, just make sure that it's secured, that it's not dragging, that there's not any damage externally to it. Make sure that you've got the correct cable on the 7-way so that it is ABS rated and can handle the current. A lot of times these will just be old. Maybe they got drug around, maybe they've just been plugged and unplugged so many times that they don't have good connection there at the 7-way anymore. So changing these out can solve a lot of problems. But just making sure that you have the right cable and that it is working. Typically when we see people test this, the first thing that is done is take a multimeter, stick it into the ends of the cable, and turn on the truck, see what the voltage is. And a lot of times people will see 14.2, 14.5 volts, well above that 13.8 range we need. And then they'll plug it in, and all of a sudden that voltage drop scenario will happen again. It's really important to, and I'll go to the next slide, it's really important that when you're testing these cables that you test them under load, because you won't actually see that voltage drop until there's a load applied to the circuit. So if you're just testing it with a sitting circuit with no load being pulled on that cable, you'll just see the power coming from the tractor, and it'll be good and everything will look fine. But as soon as you plug it in, it starts pulling that power along the circuit. That's when you have the issues. And that will only show up if you're actually testing it and monitoring the circuit while it's under load. So this is a tool that we do make, and that I, as all of our sales team and technical team have with them. But essentially what this is it's a 20 to 25 amp, it pulls 20 amps, but it's a 20 amp load that gets pulled through you can plug it into the 7-way, turn it on, and it will pull that load through the circuit. You can plug in a multimeter and actually see what that drop is doing. Whether you use this or another tool, that's up to you. But it's just really important, whatever you do, to pull a load through that circuit so you can properly see what's happening to it while it's under load and get that proper test.
Same goes. You could also flip that around and use it to actually charge the liftgate, or turn on our system and charge the liftgate batteries and test the functionality of the system itself. If you're in a spot where it's kind of hard to get a hold of a tractor, kind of like we are, if we're on the road, it's really tough for us to get a hold of a tractor to charge and test the system. This will do that for you and make it a lot easier.
Yep. Yeah, that's exactly right. So I believe that is it as far as our diagnostic goes, but a couple things, like I mentioned in the resource tab down at the bottom, we have our diagnostic guide. We also have a checklist that if you're receiving a trailer, it just kind of walks through the steps of things to look for. Whenever you receive that trailer, make sure X connection is right. Make sure, just kind of the specific things to look for to make sure everything was installed correctly and that, you're receiving the trailer that you asked for with everything working as it should. We also, for this webinar, have a special going on. If you do need any tools or think any of these would be helpful, we have special pricing with this webinar promo code down at the bottom. It is WebinarJF, and that expires at the end of next month. So we've got that for a little longer. We have our multimeter kit, and we also have our double check that we talked about that will help diagnose that system. The $585 price is for the full kit that has attachments for the 7-way, dual pole, and single pole. We also have more specific kits that are just for the 7-way or just for the single pole, dual pole. and those are $490. So if you kind of have more specific, if you know exactly which circuit you're looking for, don't need the whole kit and caboodle, then you can then we have that price as well. But feel free to reach out to us if that's something that you'd be interested in, and we can help you out on that. So we've got about 13 minutes left before our 1 o'clock time hits. So we'll go ahead and take some questions if anyone has some. And then we'll also obviously be happy to do so afterwards as well.
And stick around till the end too. There's going to be a survey at the end. Kind of let us know how we did, and if there's any other topics that you would like to learn about. So.
Okay, not seeing any questions come through at the moment. I know we answered some throughout the webinar, so we'll give it another minute or so, but we'll go ahead and start wrapping things up. Again, if any questions do come up or anything comes up that you need from us, our information, I believe, is in our bios, but we also have reach out through there. We have all of our information on there as well, and we would be happy to help however we can or answer any questions that you might have. So Thank you all for joining, and we'll go ahead and put that survey up unless you have anything else.
Well, we did have one question just roll in, I think. Maybe.
Okay. Oh, yeah, just a reminder from someone else on our team to just remind you that we do have webinars for other systems and other products that are online on our website. We also have videos on our website and on YouTube about diagnosing different pieces of this, using a multimeter, things like that. So if you've got any questions about any of our other systems, that's a great resource for you to use. And we also have webinars coming up here to in the next couple months to diagnose some of our other systems and just diagnose some other electrical issues that you might run into. And last thing, sorry, we've got a few things coming in now. Last thing, someone just asked for our phone number. Our main line is 479-419-4800, and they can connect you to whoever is best suited to answer the question you've got, or whoever is in your area. That's probably the best way to go about it if something does come up. Just call that main line, and they can put you in touch with whoever you need to be.
Also, our boss, Larry Rambo, he'll be on XM Road Dog Network on November 5th at 10 o'clock, 10 a.m. That's Tech Talk with TMC, so that might be a good one for you to tune into and kind of learn some stuff. So just wanted to throw that out there as well.
But anyway, on that note, we will wrap it up. We'll put up the survey, and again, please feel free to reach out to us anytime we can help. Thanks again for joining.